Today we're going to talk about transformation of functions. This is going to be the first topic for this section. Then later on we're going to discuss operational functions. And these are mostly reviews of college algebra. Just to make sure that everybody remembers, there's a theorem about graphing. If you're given a graph of a function, y equal to f of x, and there is some change into the function. For example, let's assume c is a fixed constant and it is a positive value. If you add that constant to the function, so if you say y equal to f of x plus c, what have you done is you've taken the y values from the function f and you've added extra c to it. So all the y values have been added to the constant c. So what happens? The x values do not change, but the y values have been shifted up by c unit. So this is kind of a vertical shift, c unit upward. So if you change function by adding a constant or subtracting a constant, so f of x minus c, this is again, you're changing the y values, you're shifting the y values of f just by adding or subtracting that constant, you're changing it up or down. So there is a shift downward c unit if you're subtracting that constant. So there is sometimes change inside the function. Instead of changing the y values, now you're changing the x values. Instead of changing the output, you're changing the input. Function y equal to f of x plus c inside, x plus c, whatever you changed is the x values. And how much you've changed the x values? You've changed it by moving its c unit in opposite direction. So for example, let's say if I tell you that f of 1 is 3, then ask you what is f of 1 plus c, you cannot tell me what that is. C is, for example, 2. You do not know what f of 3 is. But if I tell you that I have f of something plus 2 equals to 3 and ask you figure out what the number is, you're just comparing these two. You should say, okay, if I pick -1 for that question mark, then f of -1 plus 2 is -1 plus 2 is 1, so f of 1 is 3. Therefore, this question mark is basically your x value. F of x plus 2 becomes 3, therefore x must be -1. So all this is just to say, if you're making a change inside the function, what have you done is, instead of starting from 1, now you shifted the x values 2 units to the left. You go opposite direction. 1 minus 2 becomes -1. So if there is a change inside the function, if it's x plus c, then you shift it horizontally. You only change the x values. So there's a horizontal shift, c units to the left. And if it's x minus c, f of x minus c, then there's a c unit shift to the right. All the operations that are happening outside the function, they're going to be exactly the same direction. So if you add constant or subtract constant outside the function, you shift up or down vertically. If it's inside, you do opposite. F of x plus c inside, it would be c unit in the opposite direction. F of x minus c, it would be c unit to the right instead of subtract, if we're going to the left. What if you multiply a function by a constant? If you multiply a function f by a constant c, what happens is you're just rescaling. This is the y values of the original function. You're rescaling those y values by this constant. So what happens is, if c is greater than 1, then you're stretching the graph. If c is less than 1, like 1/2, all the y values get multiplied by 1/2, so all the y values become smaller. So you're shrinking the graph. That's why I said shrink or stretch depending on the constant c. This is if c is less than 1, and the other one is if c is greater than 1. So this is a vertical change because, again, you're changing the y values. And how do you change it? Either you stretch it or shrink it. If you multiply the x values by c, again, it's an opposite operation. So either you stretch or shrink. If c is greater than 1, then you have to divide the values. So it becomes shrinking. And if c is less than 1, then it's a stretch. And this is a change in the x value, so therefore it's a horizontal shift. And so these first 4 are shifting transformation. These two are stretching or shrinking. Stretch or shrink. And these two are reflection. Let me shorten it. The reflection. Okay, if you multiply a negative outside the function, what happens? All the y values get multiplied by that negative. So if the y values are positive, they become negative. If they're negative, they become positive. So what happens is you have, let's say you have some graph, something like that. This y value, if you multiply a negative to it, it will exactly come down here. This y value will move down here. So what happens is you're reflecting this graph. You're reflecting the graph about the x-axis. On the other side, if you multiply a negative to the x, what happens is if there is an x value here, you move it to the next left side. If it's on the left side, by multiplying a negative, you make it to the right side. So what happens is you're reflecting the graph by the y-axis. I'll show you examples of most of these. But this theorem is actually just helps you to start with a simple function and generate more complicated ones. So here's, for example, given the graph of x squared, y equal to x squared, we already know y equal to x squared. How does it look like? It's a simple parabola. Yeah, you can always figure out a couple of points. 0 and 0, 1 and 1. You can have 2 and 4. And the same. -1, -2, and so on. Okay, they say use transformation to graph y equals x minus 1 squared minus 2. Okay, let's say first there was no -2. Let's ignore this. And they ask you graph y equals x minus 1 squared. Starting from x squared, what happens? How do you get to this function? You've changed the x values by subtracting it from 1. So you've changed the function from being f of x to f of x minus 1. This is what we done. If this is y equal to f of x, you've changed all the x values to f of x minus 1. Then this -2 outside is just an outside. So this is basically the operation. The first step is you deal with this inside. This is a horizontal shift. How many unit? 1 unit. In which direction? In the opposite direction. If it's -1, so you go right. Step 2, after I graph that function, after I deal with this, then I will deal this with -2. What happens with -2? This is a vertical shift because it's outside. 2 unit, which direction? Downward. Okay, so I start with this original function. I operate these two transformations. So through the first transformation, where do I end up? Shift the graph 1 unit to the right. This origin will move here. 1 and 1 will move to 1, 2 and 1. This would be 3, 2, 1, 4. So 2 and 2, these points, I'm shifting these points, as well as the curve will move as well. So 3 and 4. -1 and 1 will move to -1 and 0. Sorry, 0 and 1. And -2 and 4 will move to -1 and 4. So now the graph is like that. This is the graph of f of x minus 1, which is basically x minus 1 squared. And finally, if I'm looking for the graph of f of x minus 1 minus 2, then I will shift it down 2 unit. You can plot it back to back on the same figure, so you don't need to draw this over and over. So I'm going to do this for 1 or 2 examples. This way you know what's going on. So now this is a vertical shift from this function. This is first step, then now to the second step. I'll shift this first graph to down 2 unit. Here, this point 1 and 0 will move down 2 unit to 1 and -2. at point 2 and 1 will move down to 2 and -1. And you'll have 3 and 2. Let's assume this is 2. And so on. You'll have this point, you'll have that. Try to pick a couple of graphs always. Yeah, there you go. That's the graph of y equals x minus 1 squared minus 2. But if you're given this function, y equal to x squared, it's simple enough just by doing transformation to graph y equals x minus 1 squared minus 2. It's nothing complicated as long as you know which transformation to use and the order. The order does matter. If there is a reflection or scaling involved, definitely the order does matter. In this case of shift, maybe it doesn't really that much affects anything, but for when you deal with coefficients, it makes a big difference. But here is another example. This is just to remind you of the graph of sine as well. Given the graph of y equal to sine x, so let's say we know the graph of y equal to sine x. I'm going to graph it over an interval of 0 to 2 pi. This graph continues on both sides, so it goes on and on, or over and over. So here is, this is pi, this is 2 pi. That one here is 1. This is -1. Okay, so this is the graph of sine. What do we want to graph? We want to graph y equals 2 sine x minus pi half plus 1. So starting with the f of x function, y equals to f of x. This is 2 times f of x minus pi half plus 1. So what are the operations? First step, you deal with the inside. That's a horizontal shift. How many unit? Pi half unit. Which direction? Opposite direction. So therefore to the right. Step 2. After I deal with that, I will deal with this coefficient. Coefficient outside, it's a vertical stretch. In which direction? It's a vertical stretch, so all the y values multiply by 2. And by how many units? By a factor of 2. Factor of 2. That means all the y values get multiplied by 2. That's what it means. This step 2 means y times 2. The x's do not change, it's the y values that change. Step 3, this constant 1. So this is step 1, step 2, step 3. Dealing with that constant 1 is a vertical shift. 1 unit, since it's outside, so it's upward in the same direction. Okay, so let's do this step by step. First, deal with this horizontal shift, pi half unit. By the way, this is pi half right in the middle here. So I'm going to shift the graph pi half unit to the right. And there is pi half again here. Negative pi half. So if I move it, what do I get is this graph will shift. That point 0, 0 will shift pi half to the right. It becomes here. It'd be at pi half. At pi half, I'll have this graph happening. There you go. This is pi now. Pi half plus pi half will move. So every point is moved pi half unit to the right. So 3 pi half and 2 pi and so on. And this is 5 pi over 2. This graph continues, by the way. Okay, and the same direction on the other side. So this is step 1. Step 2 is to rescale the graph. How do we rescale it? We do not change the x values. We stretch it along the y values. So that means all the y values, this is 1, this is -1. All these y values gets multiplied by 2. Here is 0 y value. 0 y value multiplied by 2 is still 0. So it's still going to be at this point. But that pi If you multiply the y value by 2 instead of 1, it becomes 2. So this would be 2. As well as at this point at 0, it becomes negative 2. So the graph is kind of stretching along the y values. Looks like not that wobbly, but kind of look like this. Hopefully you get the idea. 3 pi half, and so on. So all the y values get multiplied by that factor of 2. And the third step is a vertical shift 1 unit up. So finally, graph the function. I can draw a straight line. Therefore, now the graph is shifted up 1 unit, so it becomes -1. Here, 2 will go to 3. I'll try to graph the same thing. Not even close to what I'm trying to graph. Okay, so this point here would be pi half with the y value of 1. This is pi half and 0 moved up 1 unit, pi half and 1. Here would be 3 pi half. And y value of 1. This is pi and so on. So everything is moved up 1 unit. And this is basically the graph of 2 sine x minus pi half plus 1. It looks complicated, but if you start from sine and do this transformation, you end up with this graph, which is basically a similar shape to sine function. Here's another example of it. This one, you see the coefficients are 1/2 and pi x. I wanted to show you that there is nothing complicated, even if you're dealing with coefficients like pi or pi half. It's the same thing. So here, start with the sine function again. Maybe I should change it to cosine, so you guys have seen cosine as well. So let's try cosine pi x. Cosine, similar to sine, but it starts from 1 down here, then up here. And this is 1, this is pi half, pi, 2 pi. If you draw one full period of the function, you do not need to continue, as they always have the same shape. This means that you will see the same graph over and over. I'm going to avoid regraphing. But in general, you should continue. Okay, so this is cosine function, cosine x. What happens with cosine pi x? Because you're trying to graph 1/2 f of pi x. That pi inside, first step, dealing with this pi inside, this means all the x values will get divided by pi, because it's an opposite operation. If it's multiplication here, you divide by that. So there would be shrinking horizontally, horizontal shrink. And by what factor? By a factor of pi. That means all the x values get divided by pi. And step 2, after dealing with that coefficient, then we have vertical. Again, you're multiplying a number, 1/2, to a function, in this case outside. This is a shrink again, by a factor of 1/2. That means all the y values get multiplied by 1/2. That's why it's shrinking. If it was multiplying by 2 like the last one, it would be a stretch. Okay, so now let's try to graph this function. Okay, x value is divided by pi. This point here has x value of 0, so it stays at the same value. This one has x value of pi half divided by pi, it becomes 1/2. So it moves to 1/2. This one, pi divided by pi is 1. Then you would have 3/2. And finally, you would have 2. 2 pi divided by pi is 2. So you would have these points. Sorry about that. Point is down here. Okay, so the graph would kind of look like this. So if you compare the graphs, this graph has been shrinked along the x-axis. It's a horizontal shrink. And then in the next step, what you need to do is basically multiply all the y values by 1/2. If you do so, what happens is instead of having y value of 1 and -1, the y value is divided by 2 becomes 1/2 and -1/2. Multiplying by 1/2 is basically dividing by 2. So it looks like, and this is 1/2 as well. 1, 3/2, and here's 2. Therefore, this is the graph of f of x, f of pi x. Maybe I should say cosine. Cosine pi x 1/2 times. Okay. If you do it step by step, you do not make mistakes. So try to do it step by step. Oh, by the way, I didn't try multiplication of a negative number. What if there was negative here? -1/2. What happens now? There is this third step. All the y values, this is a reflection about x-axis. So what happens is you reflect the graph, which is a different color. You reflect the graph about the x-axis, so you will get this would be -1/2 cosine pi x. Reflection is the easiest part. Transformation, this scaling, shrinking or stretching, this is the one that maybe most of the time causes problem. Okay, this is for the transformation. Now let's discuss operation on functions. There is some similarities between what you do in general and notation, but I want to show you these notation as well. So here, if they say f and g are two functions, and f plus g of x means basically add the function f of x plus the function g of x. F minus g of x means f of x minus g of x. So it means add the two functions or subtract the two functions. If there is multiplication between them, multiply the two functions. If f divided by g of x, that means f of x divided by g of x, with the assumption that the denominator is not 0, otherwise it's not possible. Here's a simple example. You do not basically need that much information about this, but it's important to know that sometimes you have to be careful with the denominators. So f minus g in this case means find the x squared minus 2. This is the f function. Subtract it from the g function, 1 plus square root of x. You can simplify it to x squared. -2 minus 1 becomes -3 minus root x. You should distribute the negative sign. You can put them in order if you want, minus. They can ask you to evaluate. F times g of 1 means f of 1 times g of 1. Find out what is f of 1. F of 1 would be replace 1 into the function f, so 1 squared minus 2. 1 squared minus 2. Multiply by g of 1, which is 1 plus square root of 1. This is -1 times 2, which is simply -2. How about g divided by f of 0? That means g of 0 divided by f of 0. It's nothing complicated. It's just want you to see the notation. 0 squared minus 2 divided by, sorry, this is not the g function. 0 squared minus 2, 1 plus square root of 0, which is 1 divided by -2, -1/2. The only thing that is important that the domains are kind of becomes complicated when you deal with division. Not simply the intersection of the domains, but let's say if they ask you to find out what is domain of f times g, let's say f minus g, we already have f minus g of x. You find the function, and now figure out what is the domain of this function. Domain is, you cannot have negative number underneath the square root. So therefore the domain would be all x values greater than or equal to 0. Or you can write this interval 0 to infinity. Okay, so if you're dealing with the operation, make sure that you find the function first without simplifying it, then try to find the domain. Okay, composition of functions. This is the part that is kind of important, because later on when you discuss chain rule, you deal with this composition of functions in the derivatives as well. So here, I'm going to focus on this. Composition of function means f o g of x. It means if you remember the notation of a function, you have a function that maps a point to another. This is through f. So for example, 1 goes to 3. And you want to find out, what if there was another function that operates on that 3? Where does it end up? Let's say it ends up at 5. So now, can I show this through one function? Instead of going to this middle step, can I jump ahead from 1 to 5? This is what that composition is doing. That composition is called the GOF of x. It skips this middle step. First, x goes into f. For example, 1 goes into f. What we get is 3, then 3 goes into g. This is the notation, that's what it means. FOG means the other way. G acts first, then f acts. This is FOG of x. So here, FOG of x, that means g function operates first, then after that operation, whatever you get, it goes into the function f. GOF means f operates first, so find out what is f of x, and put the result into the function g. It's in the same order that you write. GOF, that means f acts first, then it goes into g. We read through right to left. Okay, so here's a bunch of functions, f, g, h, and k, and let's try to figure out a couple of these. FOG of x would be what? Means f of g of x. This is what it means. What is the gx function? Gx is given x plus 3, so I'm going to replace x plus 3 instead of gx. So now, I ask you, what is f of x plus 3? Every time you see x into the function f, you replace x plus 3. So this means I have square root of x plus 3. Simple as that. It's just important that you do it step by step so you do not make a mistake. What is the domain? Domain is always after you find the function. Before simplifying it, you find the domain. What is the domain? X plus 3 must be greater than 0 or equal to 0. Therefore, x is greater than or equal to negative 3. As an interval, this is negative 3 to infinity. That is the domain. How about GOF? I want to show you that the order does matter. What is GOF? GOF means g of f of x. F of x is square root, so this is g of square root of x. It means into the g function, every time you see x, replace square root of x. So you get square root of x plus 3. And now you see the difference. This one 3 has is underneath, this one is not inside. So there is these are two different functions. They're not the same thing. Just because the functions are simple, they're similar, but not always you will see this similarity. So x square root of x plus 3, what is the domain of that? Underneath the square root must be positive. X must be greater than or equal to 0. So therefore, 0 bracket to infinity. And you see even the domains are not the same thing. Okay, one more. FOH. f and h. F is the square root, h is x squared. So here I'll say f of h would be f of h of x. H is x squared, so f of x squared. Let me go up again. H of x is x squared. So now into the function f, I replace x squared every time I see x. So I should get square root of x squared. Let me write the f and g function. F of x is square root of x. H of x is x squared. You might ask yourself, can I simplify this? Yes, you can simplify it and say x. But before simplifying it, you always have to discuss the domain. To find the domain, you always do it before the simplifying. What is the domain? Is it all real numbers? Yeah, x squared is always positive. So therefore the domain is, this is always true. So the domain is all real numbers. Okay, so here, what if we look at HOF? I want to show you HOF as well. HOF of x. HOF of x would be h of f of x. This would be h of f of x is square root of x, which is into the function h, every time you see x, replace square root of x. So I have square root of x squared. The function h, into the function h, instead of x, I replace square root of x. This is again equals to x, but there is a big difference. Here's the domain. Domain for the square root of x is underneath the square root must be positive. X must be greater than or equal to 0. That means this domain is 0 to infinity. It's not all real numbers. That's the difference. And you should know that these two are inverses of each other. You take a square root of something and square it, you always get the same thing back. If I take a square root of 9, say this is 3, and if I 3 square, what do I get is originally 9. I go back to the same thing. This is the inverse property. That's why you will end up with the x. Okay, so it's important that even if you change the operation and end up with the same function, sometimes you may not get the same domain. So make sure that it's the same thing. By the way, this is not truly x. This is absolute value of x in the top one. You can never have negative there. The result of that square root of x squared is the absolute value of x. This is one thing that you should be careful with. But this one is x. Okay, KOG. Let me write the k and g function. K function is sine x plus 2 to the x, and g function is x plus 3. K of x was sine x plus 2 to the x, and g of x was x plus 3. Okay, so here we're looking for the composition. It would be k of g of x. G of x is x plus 3, so k of x plus 3. So now into the function, the k, every time I see x, I'll replace x plus 3. So instead of this x as well as that x, I'll replace x plus 3. So I'll get sine of x plus 3 plus 2 to the power x plus 3. What is the domain? Domain of sine function is all real numbers. Domain of exponential, all real numbers. So together, all real numbers. Not always easy to find the domain, but in this case, simple enough. Okay, I think this is examples enough for the composition. Sometimes they ask you to go backward. For example, they will give you this function and say, can you break it up into two functions like k and g? This is what I'm going to talk about as the decomposition, going backward. So for example, if you're given capital function f as sine x squared plus x, and ask you to find the two functions f and g such that their composition becomes this capital F function, could you do that? The idea is always similar. You say, okay, let's rename stuff. What if I call this whole thing inside as a new function and call it g? What do I get? I have g of x as x squared plus x. So what do I have is sine of g. If you call this sine of g, I can say this is the same as f of g. So what is my f function? F function is simply sine, but f of x, not f of g, so sine of x. This is just a simple example to see how to decompose. You start from the inside and call the function, then continue going backward and backward and call the other function. You should always have this x involved. And you can, this is not a unique solution, by the way. You can have multiple solutions. I can have g of x to be simply x, f of x to be exactly sine x squared plus x. But normally you try to pick the simplest case, which is this one. Try it from the inside, try to break down the function into simpler form, because you haven't done much in this case. Decomposition is not what I'm focused on. Most of the case that I care about is this composition, but the decomposition is, you might see examples in the homework. I just wanted you to see it. Okay, this is for 1.3. I'm going to stop at this point.